This is our architectural mock-up for the Arch project. So the installation is going to be in Las Vegas. So what we have here is something a little bit unique, something that we haven't tried before. So what we have is a laminar device. So typically these are used in interactive dry decks and different larger water displays, where we have a crystal rod or a sort of a rod of water in a parabolic curve. So in this instances, the client wanted to see if we could actually generate sort of a rain curtain effect. And so what we've done, and what you'll be able to see, is that we've inverted the actual laminars themselves. So what they are doing is shooting down. And so within this test, what we wanted to do was try to see how close we can actually get these streams together to make sure that we still have a quite high visible effect in itself. And then we also wanted to look at the illumination. So as a lot of people know, with the laminar, it does act like a fiber optic. So the light will travel through that glass rod of actual water in itself. And then when it picks up on air, you see the actual light itself. So as you can see with the water falling, once in a while you'll see these flashes, which is actually the air entrapped in the actual water stream. And so it actually illuminates it. So if we go up a little bit closer, what you can see in the actual splash is the actual light is constantly illuminating down. You just don't always see it. Also what we have in the pool, and part of the test, is also to confirm the splash radius. So like most mock-ups, what we're trying to do is mitigate any of the risk or the liability of sort of the water and how it may escape the actual system. So there's a couple of different things that we're trying here. We have tried some stainless steel grating to see how that will actually break up the actual water stream and reduce the amount of splash. This here is actually a fiber mat, so it's actually a splash suppression mat on a fiberglass grating. It's a 1-inch grating, and so what this does, and as you can see, it breaks up that water stream and it stops any sort of recoil from the water hitting or the water stream hitting the actual base and then coming out. Other things that we were doing was, again, just to confirm that the feasibility for accessing and maintaining the actual water feature. So if we look up into the actual structure, you'll see they're actually quite close. So the water streams are on average about 4.5 inches on spacing, and what that allows for is essentially a second stack laminar to project between the two chambers in itself. So it's clear falling between. There's no real interference on that. And again, part of the actual mock-up itself was just to see how feasible it is. Does the water stream, as it passes through between the chambers, does it actually get interfered with? Is there any sort of vibration from the one below? Do we get a different aesthetic from that actual water? Because theoretically it's free falling a bit of a different height. But when we look down at the bottom, it's pretty consistent. So we're not really seeing that gravitational pull where it starts elongating the water. So it's been pretty consistent. We're quite happy with it. We do have sort of the individual feeds off of the back to have a balanced line on that will be critical for the final installation. This mock-up is just a very small portion. What we're looking at for the final installation is around 21 feet. So there may be up to 59 of these devices. So as you can imagine, it's going to be quite critical on how you actually access these laminars. There's an internal screen and filtration within each device, so they have to be removed and periodically cleaned. So part of the findings are then taken into the detailed design drawings. We're going to do mechanical electrical schematics themselves to capture the actual flow rates and some of the actual maintenance protocols. So there will be inline bag filters that'll help capture most of the debris that'll come out of the actual system. And that way we're preventing people to have to go up into the actual structure to clean out the internal filters, or we're going to hopefully reduce that. What's also interesting about this one is that on site we actually have two different elevations. So this is part of an actual swimming pool. There's a larger adult swimming pool, and then we have 8 to 10 feet where then we have this sort of rain curtain effect created by the laminars. And then there's a small or change in grade where there's a glass balustrade up about 5 feet. So what we will do with the later test is we're going to remove this black screen. Right now it gives us great contrast so we can really see the water quality. We're going to remove that so you can see clear through and get an understanding of what the clients may see on site, where you don't have a nice backdrop. So what happens when you have different elements at different distances is the water effect still visible. And so again, part of the feasibility, does it sort of validate the aesthetic and sort of the costs and the maintenance that are associated with this type of water feature?